Hello everyone, here in the section we have curves in space and their tangents. So here on this part we have vector function for upper half of the helix. This is r of t, it is equal to cosine t I plus sine tj plus tk. So here on this part we have our angle. On this part we have 0 and increases to pi over 2, then increases to pi, again increases to 2 pi at this point. So here on this part we have our point is 1, 0, 0, and where we started, here is our angle. So this increasing from 0, at this point we have p, increasing this way. So moving like this, gonna continue like this. That's why we call that helix. And this is what we have based on this part is circle, is x squared plus y squared equal to 1. So center, based on this one, center it is 0, 0, and radius it is 1. Now here definition, let vector function rt equal to f of t I plus g of t j plus h of t k. This is a vector function with domain D and L be a vector. We say that R has limit L as t approaches t naught. So t approaches t naught. So limit of RT as t approaches t naught, it is equal to L. If for every number epsilon greater than 0, there exists a corresponding number delta greater than 0 such that for all t belongs to domain, so D for domain, absolute value of RT minus L less than epsilon whenever absolute value of t minus t naught between 0 and delta. Now here example, we have this vector function rt that is equal to cosine ti plus sine tj plus tk. Then we have limit st approaches pi over 4 rt. This is equal to limit of cosine t approaches pi over 4 plus limit of sine t approaches pi over 4 plus limit of t approaches pi over 4. And this is equal to, for the first part we have, instead of t using pi over 4, cosine pi over 4, it is equal to square root of 2 over 2 I plus sine pi over 4 is square root of 2 over 2 j plus, so here instead of t using pi over 4, here we have pi over 4 k. Definition: a vector function rt, it is continuous at the point t equal to t naught in its domain if limit of this vector function, so limit of rt as t approaches t naught equal to r t naught. The function is continuous if it is continuous at every point in its domain. On this part we have derivative and motion. So here as delta t approaches 0, so this one is a change in t, the point q approaches p, so this point that we have here approaches p along the curve c. In the limit, if vector from p to q over delta t becomes the tangent vector first derivative of t, so this is r prime t, and what we have here on this part, it is delta r divided by delta t, so this is change in r divided by change in t, that is equal to r, so this one minus what we have here divided by change in t, it is delta t. So this is what we have for our prime. So our prime, it is equal to limit of this part as delta t approaches 0. So in this part we have derivative definition of the vector function rt equals to f of t I plus g of t j plus h of t k has derivative. So that means it is a differentiable at t if f, g, and h have derivatives at t. So here we have our prime t's derivative of this function. It is equal to first derivative with respect to t. It is equal to limit of what we have here in numerator. It is r t plus delta t minus rt divided by change in t. Here we have delta t in denominator. So this is equal to first derivative of this function with respect to t. So we have df over dt instead of writing derivative of, so we can write this way, and f of x. So instead of writing this way, we're writing df over dt. I plus dg over dt, so finding derivative of this part. So dg over dt times j plus, and now derivative of h of t. So here we have dh over dt k. And here we have definition for velocity vt. It is equal to first derivative of this vector function with respect to t. So this is dr over dt. And here we have acceleration. This is based on what we had for velocity. So this is equal to first derivative of velocity with respect to t. So this is dv over dt. Or in other words, this acceleration, it is equal to second derivative of this vector function with respect to t. And here we have this example in summary, the curve and the velocity vector when the t is equal to 7 pi over 4 for the motion is what we have here. So this is t equal to 7 pi over 4. And on this part, we try to find first derivative of this function. So this is our prime based on this point. So we're gonna have example for derivatives. But here we have number 1, velocity is the derivative of position. So this part is repeated. V is equal to dr over dt. This is first derivative of vector function r. And speed is magnitude of velocity. So speed, it is equal to absolute value of v. Number 3, acceleration is the derivative of velocity. So a, it is equal to dv over dt, or in other words, this is second derivative of vector function. So second derivative, here we have r divided by dt squared. Number 4, the unit vector, it is v over absolute value of v. And this is the direction of motion time t. Now here on this part we have differential rules for vector functions. Let u and v be differentiable vector functions of t. C a constant vector. So C any scalar, and F any differentiable scalar function. Number 1, constant function rule. Here we have first derivative with respect to t. So first derivative of this constant. Whenever you have constant derivative of constant, it is equal to 0. Number 2, scalar multiple rules. Derivative of what we have here with respect to t. So here we have c u of t. This is equal to c, then find derivative of this part, this function. So there's u prime t. This is first derivative of u. And here on this part we have derivative of this part, f of t times u of t with respect to t. This is equal to finding derivative of this function. So here we have f prime, and then multiply by what we have here on this part plus, and now find derivative of this part and then multiply by what we had on this part, so f of t. So we have f prime t times ut plus ft times u prime t. Sum rule, derivative of ut plus vt with respect to t. So find the derivative of each one of these functions individually and then add them. We have u prime t plus v prime t. Difference rule, derivative of ut minus vt with respect to t, it is equal to, again, same as sum rule, here find derivative of each one of these functions, but on this part we should subtract, so we have u prime t minus v prime t. Dot product rule, derivative of ut times vt with respect to t, it is equal to finding derivative of the first one, multiply second function plus ut times first derivative of second function. So here we have u prime t multiply vt plus ut multiply v prime t. Cross product rule, derivative of ut multiply vt with respect to t, it is equal to u prime t multiply vt plus ut times v prime t. So here we have the difference between these two is that here we used dot, but here is cross. And finally, chain rule, derivative of u of f of t with respect to t, it is equal to, so finding derivative of this part, it is f prime t multiplied by derivative of what we have here outside. So it is u prime of what is inside. So f prime t multiplied by u prime of f of t. Example, the equation RT, it is equal to 4 sine ti plus 3 cosine tj plus 2tk is the position of the particle in space at time t. Find the particle's velocity and acceleration vectors. Then write the particle velocity at t equal to 2 pi as a product of its speed and direction. Velocity is equal to first derivative of this function, so the r over dt, it is equal to derivative of this part. Here we have 4 times, here we have sine, so derivative of sine, it is cosine t. So here we have cosine t times I plus, and here we have 3, so writing 3 here, and then derivative of cosine, it is negative sine, so here we have negative 3 sine tj plus derivative of 2t with respect to t, it is equal to 2. So vt, it is equal to 4 cosine ti plus negative 3 sine tj plus 2k. And now finding acceleration, so use what we had for velocity and find first derivative of velocity with respect to t. So acceleration, it is equal to first derivative of v with respect to t. This is equal to, so here we have this constant 4. So 4 multiplied by first derivative of cosine with respect to t, it is negative sine. Here again we have this one constant negative 3 times. Now derivative of sine with respect to t, it is cosine t. Here we have 2, derivative of 2, this is constant, derivative of constant, it is 0. So at, it is equal to negative 4 sine ti plus negative 3 cosine tj plus 0k. Find speed and direction at t equal to 2 pi. So here we have v, and for t we have 2 pi. This is equal to 4 cosine, so instead of t here 2 pi plus negative 3 sine 2 pi plus 2k. So here cosine 2 pi, it is 1, and sine 2 pi, it is 0. So what we have here for speed, when t is equal to 2 pi, This is equal to 4 times 1, so cosine 2 pi it is 1, and here we have -3 times sine 2 pi it is 0, and here we have 2. It is equal to 4 times 1 it is 4, so 4i plus -3 times 0 it is 0 times j plus 2k. So this was our answer for velocity, and now finding what we have for speed. It is absolute value of v. It is equal to square root of, based on what we have here. So it's 4 squared plus 0 squared plus 2 squared. This is equal to square root of 20. And that is equal to square root of 4 times 5. So simplify here. This is equal to 2 times square root of 5. Now finding direction. It is equal to v over absolute value of v. This is equal to, for v, we have 4i plus 0j plus 2k. So this is 4i divided by 2 square root of 5 plus 0j divided by 2 square root of 5 plus 2k divided by 2 square root of 5. Now simplify, so here we have direction, it is equal to 2 over square root of 5i plus 0j plus 1 over square root of 5k. And finally, write the velocity as the product of speed and direction. So velocity, it is equal to, for speed we had 2 square root of 5 multiplied by, for direction we have 2 square root of 5i plus 0j plus 1 over square root of 5k. So multiply these two, it is equal to 2 square root of 5, and then this is what we have for direction. Under example, the equation RT, it is equal to 2t plus 4i plus t squared minus 3j plus 2k is the position of a particle in space at time t. Find the particle velocity and acceleration vectors. Then write the particle velocity at t equal to 1 as a product of its speed and direction. So we're going to have same steps, same as what we did in that example. So here again, finding velocity first. Vt is equal to first derivative of r with respect to t. So this is equal to, here we have 2t plus 4. So first derivative we have 2i plus, here we have t squared, so that is 2t. And here minus 3, so that is constant. That part, first derivative of constant, it is 0. And first derivative of t with respect to t, it is 1. Now finding what we have for acceleration. So at is equal to first derivative of v with respect to t. It is equal to, so first derivative of 2, here we have constant, that is 0i, plus, here we have 2t, so first derivative it is 2, plus, here again we have constant 1, it is constant, so that is, first derivative it is 0. Now finding v, here t it is equal to 1, so that is equal to 2i plus, here we have 2 times 1, t is 1. So this is equal to 2i plus 2j plus k. Now here we have absolute value of v. So this is magnitude, and that is equal to square root of what we had here for velocity was 2I plus 2j plus k. So here it is 2 squared plus 2 squared plus 1 squared. And that is equal to square root of 9. So this is 3. And now finding what we have for direction. So the direction of motion is the unit vector v over absolute value of v, or velocity over speed. So this is equal to, for velocity we have 2I plus 2j plus k, and for speed we have 3. So this is 2 divided by speed, it is 3I plus 2 divided by 3j plus 1 divided by 3k. And finally, write velocity as a product of speed and direction. Speed was equal to 3, and here we had direction. So velocity is equal to 3 times 2 third I plus 2 third j plus 1 over 3k. Example, the equation RT is equal to 3t plus 7I plus square root of 5tj plus 2t squared k is the position of a particle in space at time t. Find the angle between the velocity and acceleration vectors at time t equal to 0. So first I'm going to find velocity and acceleration. So velocity is equal to 3I plus square root of 5j plus 4tk, and acceleration, it is first derivative of velocity, so that is equal to 0I plus 0j plus 4k. Now instead of t, we're going to use 0 because here what is given was t equal to 0. And find what we have for velocity and acceleration. So here velocity when t is 0, it is equal to 3I plus square root of 5j plus 0k. And acceleration when t is 0, it is equal to 0I plus 0j plus 4k. Notice that the acceleration vector does not depend on time. So based on what we had here on this part, we didn't have t, so I didn't use t equal to 0. I didn't really plug in 0 for t because we didn't have t on that part. That's why it doesn't matter what we have for t, we're going to have same answer for acceleration. So the angle between two vectors can be found using the dot product. So here, our angle theta is equal to r cosine u times v divided by absolute value of u multiplied by absolute value of v. So find the dot product of v and a, velocity and acceleration. And this is equal to, here we have 3 for velocity and 0, so 3 times 0 plus square root of 5 times 0. And here we have 0 times 4, so this is equal to 0 plus 0 plus 0, and that is 0. So dot product is equal to 0, and because of that, we don't need to find magnitudes, because here we're going to have r cosine 0 divided by any number is 0. So theta equal to r cosine 0 over theta is equal to pi over 2. Now here example, the tangent line to a smooth curve RT is equal to f of t I plus g of t j plus h of t k, at t equal to t naught. It is the line that passes through the point f of t naught, g of t naught, and h of t naught parallel to v of t naught. The current velocity vector at t naught. So use r t naught and r prime t naught to find parametric equations for the line that is tangent to the given curve at the given parameter value t equal to t naught. So what we have here for rt is equal to 2 cosine ti plus t cubed minus 3 sine t j plus 4 e power it is t k t naught it is 0. First find the position of the particle at t naught equal to 0. So here we have r0 that is equal to 2 cosine 0I plus 0 cubed minus 3 sine 0j plus 4 e and power is 0. And here we have k. So this is equal to 2 cosine 0 it is 1. So we have 2 times 1 it is 2i plus, here we have 0 cubed, so that is 0 minus 3 times sine 0 it is 0. So we have negative 3 times 0 it is 0j plus 4 times, here we have e power 0, so this part it is equal to 1. We have 4 times 1 k. So based on what we have here, the tangent line passes through the point 2, 0, 4. And now finding what we have for velocity, it is equal to, so we have 2 times first derivative of cosine based on what we have here. So first derivative of cosine with respect to t, it is negative sine. Then here we have t cubed, so first derivative of this part, we have 3t squared minus 3 times derivative of sine, it is cosine, plus 4 times e power t. So, and now finding what we have for velocity when t is 0. This is negative 2 times sine 0 I plus 3 times 0 squared minus 3 times cosine 0 j plus 4 times e power 0. Then here we have k. So this is equal to, then simplifying what we have here, sine 0 it is 0. So this part here is 0. We have negative 2 times 0, it is 0. Then this part it is 0. Here we have cosine 0, it is 1. 1 times negative 3, it is negative 3. Here we have e power 0, that is 1. So 1 times 4, it is 4. So here this is equal to 0i minus 3j plus 4k. So this is what we have. In general, the standard parameterization of the line through P naught parallel to vector V is x equal to x naught plus t times v1, and y it is equal to y naught plus t times v2, and z it is equal to z naught plus t times v3, where t is between negative infinite and positive infinite. And what we have on this part, the tangent line passes through this point 2, 0, 4, and is parallel to what we had here on this part, 0i, negative 3j, plus 4k. Find the standard parameterization for this line. So based on this point, here we have x naught, y naught, and z naught. So x is equal to x naught, it is 2, plus here using what we have here, it is 0 times t. So this is v1, v2, and v3. v1 it is 0, v2 it is negative 3, and v3 it is 4. Now y is equal to y naught, it is 0 plus negative 3 times t, and z is equal to z naught, it is 4 plus, here we have 4 times t. So that's one, the one that we have for x, this is equal to 2. This is equal to negative 3t. And this is equal to 4 plus 4t. Vector functions of constant length. If a particle moves on a sphere in such a way that its position r is differentiable function of time, then r times first derivative of r with respect to t is equal to 0. If r is differentiable vector function of t and the length of rt is constant, then here again r times the first derivative of r with respect to t, it is equal to 0. Now here example, the vector function rt is the position of a particle in space at time t. Determine the graph of position function. So here we have this function rt, it is equal to 3t squared I plus t squared plus 5j plus 2t to the 4th power k. So first parameterize the vector function. Here what we have for x is equal to 3t squared based on what we had on the support, y equal to t squared plus 5, which is the support, and z is equal to 2t to the 4th power. Next, determine the domain. The domain is the largest set of points t for which all three equations that we had here are defined. The domains for each of the three parametric equations are all real numbers, so it's negative infinite, positive infinite. So the domain for the vector function is the negative infinite, positive infinite. Graph the functions x equal to 3t squared, y equal to t squared plus 5, and z equal to 2t to the 4th power on this interval, which is negative infinite, positive infinite. So here for t, I used 0, 1, 2, 3, these points, and here is what I have for x, y, z. When t is 0, x it is 0, y it is 5, and z is 0. When t is 1, x is 3 because we have 3 times 1 squared. Y it is 6 because we have 1 squared plus 5. And z is 2 times 1 to the 4th power, so that is 2. So now t equal to 2. Based on that, x is 12, y is equal to 9, and z is 32. And here t equal to 3. So x is equal to 3 times 3 squared, that is 27. Y is equal to 3 squared plus 5, so that is 14. And finally, z is equal to 2 times 3 to the 4th power, that is 162. This is our graph, and I used GeoGebra. I used the first 3 points that I had was 0, 5, 0. Then I had 3, 6, 2, 12, 9, 32. So the first one, here is A, we have B, and here is C. If we connect all these 3 points, you're going to have what we have here. So this is 3D. We have X, Y, and Z. So this is what we have after connecting all those 4 points. But on GeoGebra, I did 3 points here. So this is what we had based on GeoGebra. So what I did on those parts, I selected 3D calculator, and then so here I use tools. Here is point. Then I typed in a equal to, so parentheses 0, 5, 0, close parentheses. I did same thing for these all these 3 points. So for the first one I used A, then here I use B, and here I use C.